Hello AP Chem, this is the first in a series of videos that we will need to do because they have to cut them into short parts to make it all work out. Anyway, on chemical kinetics, and you should get a packet there at school, and you can write some of this down on there if you want, and then there'll be some problems later on. So, chemical kinetics has to do with rates of chemical reaction, or how quickly your reactants become products. Typically we use units of moles per liter per second or per minute, but other things are possible. If you're looking at like radioactive decay, it's in the thousands, if not millions of years sometimes as the time unit. So just be aware, but the frequently, or most typically, we're going to use moles per liter per second or moles per liter per minute. So here's an equation. Oops. 2HI gas makes hydrogen gas plus iodine gas, and we could measure the rate of disappearance of the HI, or the rate of the appearance of H2, or the rate of appearance of I2, whichever is the most convenient is what we'll use, and it doesn't matter. Once we know one, we can calculate the others from the stoichiometry. So we will try to remember that equation as we move on to the next page. Here is a graph of what's happening in this equation. The black curve being the rate of HI disappearance. Notice since it's disappearing, it's getting smaller. And the H2 is appearing, so that is getting bigger. The rate formula that we use is very similar to the slope formula you used to use when you were in algebra class. It's just a difference in the y's over a difference in the x's. In this case, y is concentration and x is time. And so the change in concentration, that's what the triangle there means, delta, which means change in. So the change in HI concentration over change in time. I've picked this point here at time 30 seconds. The concentration is 0.5. And so you can see that 0.5 is your final concentration. Minus 1.0 is the initial concentration. We're looking at this guy right here. And the time change went from 0 to 30 seconds. It's decreasing. This is really just the slope, so it's negative 0.50 over 30, which is 0.0167 moles per liter per second. That'd be seconds to the minus 1. Okay. And then the H2, we'll notice that it is going up from starting at 0, but it's not going up quite as fast as the HI is going down. In fact, we've noticed from the stoichiometry, this was a 2, this was a 1, so it's only going half as fast as the HI, and that's reflected there in that curve. We could calculate the instantaneous rate at any time along the graph there, and I've got the approximate concentrations down here at the bottom, and so we can see that, well, let's just go to the next page. So the rate, I'm going to use negative a half because it's decreasing, right? Change in HI concentration over time, which is the same as the rate of the H2 concentration over time, which is the same as the I2 concentration over time. And at time 30 seconds, we said that the rate was 0.0167 moles per liter per second. That was negative because it was decreasing. So if we want to know what the rate of the H2 concentration is, it's just a half of whatever the HI concentration was, so negative a half, right, because it's negative. And this was negative. So negative a half times that number will be a positive 0.00835 moles per liter per second. So whatever the equation is, if you want to know what the rate is, it's just 1 over the coefficient, delta concentration over delta time. So hopefully you can see where all those came from. Okay, so I believe, oh, wait, one more page. So if we wanted to see what this equation here with the making of ammonia, the rate of N2 concentration over time would be negative 1 delta N2 over delta T, because the coefficient is 1, be 1 over 1, right? Negative 1 over 1, that's just 1. The H2 would be 1 over 3, negative. The NH3, 1 over 2, and that's positive. All right, so once you know one, you can figure out the other two. No big deal. All right. The next video, we're going to start in on rate laws, so I will start that in just